All right, everybody, this is Duke with an explanation video talking about altitude hold flight mode. Now, this is about as far as we get in the setup of our copters in this class. You'll go much further, of course, in the guidance and control class if you take that one that follows this class. But this is about as much as we can fit into this class, is getting you guys to the point where you can fly your quadcopter fairly well, working fairly well, and you do an altitude hold. Okay, altitude hold is basically like it sounds. The aircraft will hold altitude. It will not hold position. So that is not a GPS position hold. We don't have a GPS on our copter anyways. But this mode will not hold position laterally or horizontally. It will get pushed around by breeze and stuff and that kind of thing. But it should do a fairly good job of holding the altitude, as in it won't go up and down a bunch on you if you leave it in that middle hover position. Okay. So in this assignment, what I ask you to do is basically make sure you have decent vibrations on your copter, that the vibrations aren't too high, and then you go ahead and you set up altitude hold flight mode. Okay, the reason why we do vibrations first is because if our vibrations are too high, it's typically a physical issue on the copter. You have a loose screw or something's moving around too much there. And if the vibrations are too high, the flight controller can't measure what's actually happening on the copter. And if you try to use an automated mode like altitude hold, it can cause a flyaway situation where the copter just starts taking off on you, and you got to switch back into stabilize mode in order to control it. Okay, so no one wants to do that. That's not fun. It's kind of scary if it starts flying away by itself. So we want to make sure our vibrations are good, and we want to make sure we set up altitude hold correctly. And you should have a decent flying copter at that point. You can always take the other class and add GPS and stuff, or do it on your own. But this kind of wraps up the flying in this class. Okay, so the vibration level link here. Let's go ahead and open that. Measuring vibration in Arducopter. Okay. You guys don't have a telemetry radio, so you can't do the real-time view in the ground station. So we'll go down here to the data flash log. Now, hopefully you've already completed the log analysis assignment in class, which has you measure the vibration levels of some example logs I gave you. Okay. But this is going to be you measuring the vibration levels on your own copter that you built. Okay. The overall thing we're going for here is to check the recorded vibe levels are mostly below 30 meters per second per second. Okay, so we're going to fly our copter around, maybe on the test flight when you maiden fly the copter. Every time you arm your Arducopter, by default, it will start a log. And that works great. Just leave that setting alone. You want it to log when you're flying, so you have data about what happened. And you just fly around, you know, with your copter for a few minutes. You're going to download the data flash logs. Now you can click on this link and figure out how to do that with the link I'm going to show you as well. Okay. Once we have the log, we'll open it up just like we did in the log analysis assignment, and we'll graph the vibe message. Okay, X, Y, and Z. Right. If you remember from the log analysis assignment, this is very similar. X, Y, and Z. They've graphed those here. They're looking at the vibrations over the course of flying. Okay. And they see their vibrations are generally well below 30 meters per second per second. So that's good. That means vibrations are low enough, the flight controller is not oversaturated with vibration, it can still measure things, and your altitude hold flight mode should work pretty well. Okay. As long as you've checked that, then your vibrations should be good. Unless something changes on your copter's physical assembly or you crash or something comes loose, the vibration shouldn't really change over time. Okay. So that is kind of a prerequisite to actually doing this assignment. Let me show you how to get logs real quick in Mission Planner. Just like when we reviewed logs, we go to this Data Flash Logs tab here on the main page of Mission Planner. You scroll all the way over to get to the Data Flash Logs tab. Okay. And here we're going to say download Data Flash Log via Mavlink when we're connected to our copter via USB. And we'll get a pop-up like this, and they won't be date stamped. Mine are date stamped here because this was a GPS copter. You don't have a GPS, so your logs will all say like 1969, I think. But just grab the most recent one. If you just flew and you're getting the log, it'll be the latest log. So number 4, for example, would be the log I'd want to grab. I'll select that, and I'll hit download selected logs. Okay. And I'll download it to my computer. And once it's finished, I can then review it, just like we did in the log analysis assignment. Okay. Finding the log can be a little bit tricky sometimes until you know how to do it. We'll just go to review a log here, and it will automatically pull up. Well, mine's set a little bit different. Sorry, guys. It should automatically pull up something like this. Okay. You'll see a logs folder like this, and it'll be inside of documents, inside of Mission Planner. You'll say logs. Okay, cool. And you go to, oh, which one is it? I'm flying a quadcopter, so it'll be in the quad rotor folder there, and the number 1 folder there. And so you have a ton of logs dumped in here from lots of things, right? But you won't have that many if you're just doing this for the first time. You'll find that number 4 flight log that you just downloaded, okay? The one we just found right here, you'll find that. And once you hit review, it'll pull up, a log browser just like this. And you can look at those vibe levels just like we did in the log analysis assignment, okay? X, Y, Z. There we go. All right. You can also use the web-based viewer, just like we did in the log analysis assignment, plot.ardupilot.org. If you want to use that viewer, this one here, you can just load your log you downloaded right into here and view it that way. Okay. Whatever way you view it doesn't matter as long as your vibration levels are low enough below that 30 meters per second per second. Okay. The lower the better to a certain point. You need to have some vibration, like so the flight controller can actually tell what's going on. But I doubt many of us will ever get to the point where we build a quadcopter that has no vibration, since that's nearly impossible. Okay. So once you have the vibrations measured okay, they look like they're doing good, then you move on to the altitude hold flight mode. Okay. There are a couple of different steps to how to do this. Okay. And I'm going to tell you what you want to turn in to the assignment, then we'll talk about how to do it. Okay. Basically, you're going to fly your copter in altitude hold flight mode, and you're going to download the log after you've done altitude hold flight mode. You'll submit the log file itself to this assignment, as well as a screenshot of the log in one of the viewers. Okay, so let's say this was my altitude hold flight mode. I had my log here. Okay, let's let this load up. I don't want that. I just want the let's say I just look at my altitude here. And we're going to say, okay, I have this section of my graph. We can see that I flew this aircraft in stabilized and loiter flight modes. Okay, so you take a screenshot of that, and that would show me that you had got the right log, that you would know how to load it into a log viewer and verify you have the right log, and it actually shows the flight mode I'm looking for. Now I'm looking for altitude hold flight mode, not loiter. Okay, but the example is the same there. All right. If you do that in Mission Planner log viewer, similar thing. We'll grab our log here, okay? We will graph something to get it to show us the graph here. And we'll then go and unselect events here. And we can see the color change here, red, then yellow, then red. And we see that corresponds with stabilized flight mode, loiter flight mode, then back to stabilized flight mode. So those color bands correspond to the flight modes. So again, you would have a flight log with altitude hold flight mode showing in the log. Okay. So again, hopefully that makes sense. If you already done the log analysis assignment, which you hopefully have at this point, this will be fairly simple, okay, to pull the log off your copter and then screenshot it in a log viewer, okay, and that's what you'll turn into the assignment, all right? Now, how do we actually do the assignment, okay? So we already did the vibration levels. This other link down here talks about how to set up altitude hold flight mode, okay? You'll get to this initial tuning flight section. You'll scroll down here to where it says test altitude hold. I'll actually fix that link so it goes straight to this section. But the test altitude hold section is where we're going to set up altitude hold for our aircraft. Okay, so you're going to have basically this 3, 4, 5 paragraphs to go through. All right. Any of these blue hyperlinks are going to be parameters inside of Mission Planner. Okay. So the first thing it says, check Mott Hover Learn and set to 2. What does that mean? That means we go into Mission Planner. Get rid of that. We're going to go to our config tab. Okay. Oops, my parameters. What happened here? Looks like it's having some difficulties with the Mission Planner. Sorry, guys. Hold on. Okay, there we go. Sorry about that. So you go into the config tab, you go to the full parameter list or the tree. Okay, either one can work. There's just a list of all the parameters inside ArduPilot. There's a lot of them, right? But we're going to search for this one, Mott Hover Learn. If you go over here to the right-hand side, you start typing Mott _ hover. Okay, and then it pops up Mott Hover Learn. We want to have it set to 2, learn and save. It's already set to 2, so that's great. Okay, it will learn the hover throttle automatically. So we're going to take off in stabilized flight mode and increase altitude to 5 meters, around 30 feet or so. Okay. You're going to switch to altitude hold flight mode, which I'll show you how to do in a second. And be ready to switch back to stabilize if you need to. Okay. If it starts climbing on you and you're not controlling the copter, then go back to stabilize mode and bring it down to the ground. Okay, but typically this works pretty well if you have your vibration levels low enough. Just switch to altitude hold flight mode and try to keep the aircraft just hovering at visually a point in space. Okay, just about 30 feet in the air. Keep it hovering about 30 feet in the air, using your throttle to make small adjustments to that altitude. You want to do that for about 30 seconds to a minute. Okay, and that is basically teaching the copter what a good throttle setting for a stable hover is. So it knows, oh, I need to do 25% of my throttle. Oh, I need to do 35%. And this is different for every type of drone, but since we all have the same type of drone in the class, it should be pretty similar for most of you. Okay. You then land and disarm the aircraft after you've hovered for at least 30 seconds or a minute or so in altitude hold. Okay. At that point, you want to go and find this parameter. Okay. Mott thrust hover. So we'll go look for that one in my search. Excuse me, my search bar over here. Excuse me. I have a value of 0.349. Okay, so I have that number. I'm going to times that number by 2. Okay, so 0.39 times 2 is roughly, or 0.35 times 2. Okay, should be roughly 0.7 or so. So I'd take that number and I'm going to put it into this parameter, PSC underscore ACCZ. Okay, so let's go ahead and search for that. PSC, oops. ACC. And here we go, start getting some of these. So PCC AZZZI is right here. Okay, so you can see the default is 1, right? We want to times our number by 2. We had 0.35, so we're going to change this. Just double click on the box, backspace, 0.75. Okay, and I should calculate that more precisely, but I'm just showing you guys the example here. So we'll go with that. Once I type it in the box, I'm going to hit enter. I'm going to hit write params. Okay, and it's going to save that to my actual drone. Okay, so that's one there. I'm going to take that same number, the 0.35, and just put it straight into PSC ACCZ-P, okay, which is right here. So we'll change this to 0.5 is going to be 0.35. Okay, and we're going to write params there. And successfully saved. Great. Okay. Now you can go out and fly your aircraft in altitude hold again. Make sure it's working correctly. Okay. If it starts to oscillate, you can adjust some other values. Okay. But typically we don't have to do that with these copters. That's all you need to do to fly altitude hold flight mode and get the log file. Okay. So that should hopefully explain the parameter setup and things like that. But the one piece we haven't talked about yet is how to actually switch to altitude hold flight mode while you're flying. Okay. So let's go into Mission Planner and talk about that. In our Setup tab of Mission Planner, you may have noticed this before. Under Mandatory Hardware, there's a Flight Modes tab. Okay. And this copter has a lot of different flight modes on it. Your copter by default will just have all stabilized flight modes. That's the default with a new build, to just have all stabilized. Okay. And if you have your controller set up correctly, you'll be able to set a channel, okay, or a switch set to a channel to actually move this green bar. See how it's kind of highlighted here, green. Move it around to select different flight modes. Okay. So right now I'm in flight mode 6 out of 6. Okay. We don't need all 6 flight modes. We just need stabilized and altitude hold. So once you've assigned a switch on your transmitter to a channel, you can then move that switch around and you can get this green bar to jump around. Okay. I am on a simulated copter right now. I don't have a transmitter to actually flip a switch on. Okay. But what you'll typically do is maybe you'll set this to altitude hold in the middle. We'll just double up here. That way we have stabilized and has a nice wide band, PWM 16 all the way to the max. Okay. The middle band is 13 to 1620 and the other end of the stick is 0 to 1360. Okay. Don't worry too much about these values. It just means basically there's 3 positions for your switch. There's the top, the middle, and the bottom position. Okay, that's why you have them doubled up, because you just have a 3-position switch on your transmitter, not a 6-position switch. Okay, and so when you're flying, or even before you start flying, you can flick that switch and you can change from stabilized to altitude hold, for example. Okay, or back. Right now in the instructions it mentions a takeoff and stabilized, and then switch to altitude hold. So what you would do there is you take off with the switch in this position, get up to about 30 meters or so, or not 30 meters, sorry, 30 feet or so, and switch your transmitter switch into the middle position to get altitude hold flight mode there. Okay. Once you've done that, then you continue the rest of the exercise, hover in place for about 30 seconds or a minute or so, and finish what we talked about earlier. Okay. So that should hopefully help you get everything set up for your aircraft. Okay. Um, there is one caveat with the flight modes. You want to make sure you have the channel set up correctly if you're using Express LRS. I have a video about that that will talk about why you need to set Express LRS up differently than other transmitter systems. The default channel it wants to use for flight modes is 5, and Express LRS can't do that. Other systems can, but Express LRS needs channel 5 for a different purpose for arming the aircraft. So I'll link that video and how to set the channels up in Express LRS down below this video. Okay. All right. That should do it for this video. Thanks.